Good morning, everyone. This is Sachin Piske from Electrical Engineering Department, SND College of Engineering and Research Center. Today, we are going to start a new topic, that is position sensor. A position sensor is any device that permits position measurement. It can either be an absolute position sensor or a relative one, that is displacement sensor. Position sensor can be linearly angular or multi-axis. Some position sensor available today is a capacitive transistor. In this tutorial, we will look at the variety of the devices which are classed as input devices and are therefore called sensor, and in particular those sensors which are positional in the nature, which means that they are referred direct to the form some fixed point or position. As their name implies, this type of sensor provides a position feedback. One method of determining a position is to use either distance, which could be a distance between 2 points, such as the distance traveled or moved away from some fixed point, or by rotation, that is angular movement. For example, the rotation of the robot wheel to determine its distance traveled along the ground. Either way, position sensor can detect the movement of an object in a straight line using linear sensor, or by its angular movement using rotational sensor. What is potentiometer? The most commonly used of all the position sensor is a potentiometer because it is an inexpensive and easy to use the position sensor. It has a wiper contact linked to a mechanical shaft that either can be angular rotational or linear slide type in its movement, and which causes the resistance wall value between the wiper or slider and the two end connection to change, giving an electrical signal output that has a proportional relationship between the actual wiper position on the resistive track and its resistance value. In other words, the resistance is proportional to position. Potentiometer come in a wide range of design and sizes, such as the commonly available round rotational type or the longer and flat linear slider type. When used as a positional sensor, the movable object is connected directly to the shaft or slider of the position potentiometer, and a DC reference voltage is applied across the two outer phase connections, forming the resistive element. The output voltage signal is taken from the wiper terminal of the sliding contact as shown. This configuration produces a potential or voltage divider type circuit output, which is proportional to the shaft position. Then, for example, if you apply a voltage to say 10 volt across the resistive element of a potentiometer, the maximum output voltage would be equal to the supply voltage at 10 volts, with the minimum output voltage equal to 0 volt. Then the potentiometer wiper will vary the output signal from 0 to 10 volt, with 5 volt indicating that the wiper or slider is at its halfway or center position. Potentiometer come in a wide range of design and sizes, such as commonly available round rotational type or longer and flat linear slide types. When used as a positional sensor, the movable object is connected directly to the shaft or slider of the potentiometer and a DC reference voltage is applied across the two outer fixed connections forming the resistive element. The output voltage signal is taken from the wiper terminal of the sliding contact as shown, and this configuration produces a potential or voltage divider type circuit output which is proportional to the shaft position. Then, for example, if you apply a voltage say 10 volt across the resistive element of the potentiometer, the maximum output voltage would be equal to the supply voltage at 10 volt with the minimum output voltage as 0 volt. Then the potentiometer wiper will vary the output signal from 0 to 10 volt with the 5 volt indicating that the wiper or slider is at its halfway or center position. Some examples of the simple potential sensing circuit. While the resistive potentiometer position sensor have many advantages as it has low cost, low technologies, then easy to use, etc. As a positional sensor, they also have many added disadvantages where due to moving parts, then it has low accuracy, low repeatability, and limited frequency response. But there is one main disadvantage of using the potentiometer as a positional sensor. The range of the movement of its wiper or slider and hence the output signal often is limited to the physical size of the potentiometer being used. For example, a single turn rotational potentiometer generally only has a fixed electrical rotation between about 240 to 330 degree. However, multi-turn pot of up to 3600 degree of the electrical rotational are also available. Most type of potentiometer use carbon film for their resistive track, but this type of the electrically noise and also have a short mechanical life. Wire-wound pots are also known as a rheostat in the form of either a straight wire or wound coil. Resistive wire can also be used, but wire-wound pots suffer from resolution problem as their wiper jumps from one wire segment to the next, producing a logarithmic output resulting in error in the output signal. These two suffer from electrical noise. For high precision, low noise application, conductive plastic resistance element type polymer film or cement type potentiometer are now available. These pods have a smooth low friction electrically linear resistive track giving them a low noise, long life and excellent resolution and are available as both multi-turn and single-turn device. Typical application for such type of high accuracy position sensor is in computer game joystick, then steering wheels, again industrial and robot application. The polarity of the output signal depends upon the direction and displacement of a moving core. The greater the movement of the soft iron core from its central null position, the greater will be the resulting output signal. The resultant is the different voltage output which varies linearly with the core position and therefore the output signal has both an amplitude that is the linear function of the core displacement and the polarity that indicates the direction of the movement. The phase of the output signal can be compared to the primary oil excitation phase enabling suitable electronic circuits such as AD592 LVDT sensor amplifier to know which half of the coil the magnetic core is in and he thereby know the direction of the lever. The linear variable differential transformer, that is LVDT. When the armature is moved from one end to another through the center position, the output voltage changes from the maximum to zero and back to the maximum again, but in the process changes its phase angle by 180 degrees. This enables the LVDT to produce an output AC signal for the magnitude represent the amount of the movement from the center position and whose phase angle represents the direction of the movement of the core. A typical application of a linear variable differential transformer that LVDT sensor would be as a pressure transducer, where the pressure being measured pushes against a diaphragm to produce a force. The force is then converted into a readable voltage signal by a sensor. Advantage of the LVDT compared to the resistive potentiometer are that it linearly, that is, its voltage output to displacement is excellent, very good accuracy, good resolution, high sensitivity, as well as frictionless operation. They also sealed for the use in hoist environment. When a ferromagnetic material is placed within the eddy current field generated around the inductive sensor, such as ferromagnetic material plate or magnetic plate or metal screw, the inductance of the coil changes significantly. The proximity sensor detection circuit detects this change, producing an output voltage, and therefore inductive proximity sensor operates under the electrical principle of Faraday's law of electromagnetic induction. An inductive proximity sensor has four main components: the oscillator which produces the electromagnetic field, the coil which generates the magnetic field, the detection circuit which detects any change in the field when an object enters it, and the output circuit which produces the output signal, either with the normally closed or normally open contact. Inductive proximity sensor allows the detection of the metallic object in front of the sensor head without any physical contact of the object itself being detected. This makes them ideal for the use in dirty or wet environment. The sensing range of the proximity sensor is very small and typical from 0.1 mm to 12 mm. Now, rotary encoders. The rotary encoder resembles the potentiometer mentioned earlier, but are non-contact optical devices used for converting the angular position of the rotational shaft into an analog or digital data code. In other words, they convert the mechanical movement into an electrical signal. All optical encoders work on the same basic principle. Light from an LED or infrared light source is passing through a rotating high-resolution encoded disk that contains the required code pattern, either binary, gray code, or BCD. Photodetector scan the disk as it rotates, and an electronic circuit processes the information into the digital form as a stream of binary output pulses that are fed to the counters or controller, which determines the actual angular position of the shaft. There are two basic types of the rotary optical encoders, that is, incremental encoder and absolute position encoder. By using the arctangent mathematical function, the angle of the shaft in radian can be calculated. Generally, the optical disk used in rotary position encoder is circular. Then the resolution of the output will be given as theta is equal to 360 by n, where n equals to the number of the segment on the coded disk. Then, for example, the number of segments required to give an incremental encoder a resolution of 1 degree will be 1 degree is equals to 360 upon n, and therefore n is equals to 360 window. Also, the direction of the rotation is determined by noting which channel produces an output first, either channel A or channel B. By giving two direction of the rotation, A leads B or B leads A. This arrangement is given as follows. One main disadvantage of the incremental encoder when used as a position sensor is that they require external counter to determine the absolute angle of the shaft within the given rotation. If the power is momentarily shut off or if the encoder misses a pulse due to noise or dirt disk, the resulting angular information will produce an error. One way of overcoming this disadvantage is to use of absolute position encoder. So what is absolute position encoder? These are more complex than the quadrature encoder. They provide a unique output code for every single position of the rotating, indicating both position and direction. The coded disk consists of a multiple concentric track of the light and dark signal. Each track is independent with its own photo detector to simultaneously read a unique code position value for each angular moment. The number of tracks on the disk correspond to the binary bit resolution of the encoder. So a 12-bit absolute encoder would have 12 tracks and the same coded value only will appear once per revolution. Thank you.